ended up question 6. So let's continue. Focus. And let's enter that into our calculators. Let's see how, I guess I should read it first. It becomes easier and easier to see the headlights of an oncoming car the closer it gets. The distance, d in meters, between the car and the observer can be described by the function of the intensity, I, in lumens, of the headlight brightness. So this is how it's stated. This is our y, and this is our x, remember, every time. So that means that we have our intensity will be the x value of every point on this curve, and the distance will be our y value. Okay, so we got to make sure we understand that. That is very crucial, especially when you do logs. And so this is a logarithmic. What do we know about logarithmic functions? We know that it looks like this in general, right? Where point 1a is on the graph. If b is greater than 0 or positive, then we have something like this happening. If b is less than 0, we'll have a decreasing function. It looks like this. I have to warn you with the 1a. 1a, if a is negative, if this is a negative value, then on our graph, if I may, like, it would be below the x-axis, so you probably wouldn't want to include that every time, but it's there to help you should it be relevant. So let's enter this into our calculator. Here we go. 350 minus 72 ln is right here under log. So you got to watch out. Sometimes it's log, sometimes it's natural log. So we go natural log of x. Close bracket. I can tell that, I'm going to go back to the equation. I can tell that this is going to give me a 0.1350 on this thing, on the graph. And b is negative. So you can almost imagine 1,350 is somewhere up here. And because b is negative, this is going to come down towards the x-axis. It will cross it, right? So we know it's going to cross it at some point because it never touches the y-axis. That's something we know. So let's see. I'm going to hit graph. Don't see anything. No panic. I'm going to go window. X min, I'm going to go -5. X max, I'm not so sure yet where it hits. So I'm just going to go 100 for now. Y min, I'm just going to go below the x-axis. And Y max, I know that 350 should be on there. 1,350. So I'm going to go a little higher than that, right, in terms of my Y max. And there it is. I can see. And remember, it never touches, even though it looks like it. It does never touch if you were to zoom in. I'm going to increase my x max a little bit because until I see that it's hitting the x-axis. So x max, I'm going to make that 250 or something like that. There we go. It's probably overkill, but it's going to cross right there. So that's a good enough graph for us. Okay. It says sketch and clearly label the graph of this equation. So it's worth 2 marks. So the first thing we do is this, we call this distance. And we know distance is measured in meters here. And here we will call this intensity in lumens. There you go. And now I need a scale. I know that here, if I include 1,350, I'm good. So I'm going to go up to 400 along this. So I'm going to go and spread it out. 100, 200, 300, 400. I even go up to 500. That's not a big deal. It just has to be an appropriate scale. It doesn't have to be exactly like mine. But if you just go up at 1, 2, 3, I don't think that would be appropriate in this case. In terms of my x, I'm going to find the x-intercept. So I'm going to go y2 is equal to 0, hit graph, and I'm going to find that intersection there. Second trace 5, enter, 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 and there we go. It doesn't ask us to solve for it, but we just know that the x-intercept is 129.170. I'm going to say, right, y2 is equal to 0, second trace 5, in case you're wondering where I got this from. So I will make sure I go up to 150 at the very least along my x-axis. So here we go. Let's see here. 20, 40, 60, 80, 100, 120, 140. That works pretty good. So 20, 40, I'm going to label every other one. There you go. That is a good window here for me. If you're not sure, use whatever you have in your X max to guide you, right? So my X max was what, 300 or something? 500. No, sorry, 250. It would have been completely okay to have 250 as your highest value here. Not a problem. So 1350 is right there. And this is 129, which is very close to 130. And I would say, I would warn against just freehanding it here. I would find at least 1 or 2 more points here. So I'm going to maybe pick 50, this one, and find what the value is. I'm going to go second, trace 1, x is equal to 50. And what's y equal to? I'm doing that at the bottom there. So graph, second trace 1, x is equal to 50, y is equal to 6833. Okay, so I know that 50, 68, 33 should be on there. 68, this would be 50, right? And 68 is just above it. That is good enough. So you just come down. And just make sure you don't cross the x-axis, because within this problem, you can't have negative distance, right? The car will be right in front of you. It could be 0 meters in front of you, but it can't go past. So, and here, make sure it doesn't touch, and just have an arrowhead going up, and then you're safe. Okay. And I will, just to make sure I don't lose any marks, I will include my equation as well. That's it. We're done. Let's keep going. B, determine the distance to an oncoming car if the intensity of its headlights is 75 lumens. So basically what they're asking is if the x is 75, what is y? So you can actually use this point as well when you go back to your graph. Second trace 1, x is equal to 75, y is equal to 39.14. 39.14 meters. There you go. 1 mark for that. Next, what's the maximum intensity of the headlights? Justify your answer. When it says justify, you have to explain. You can't just give the answer. That's why it's worth 2 marks, okay? And if you're ever not sure, there are some terminologies. I don't know if I talked to you about those. If you go to the formula sheet, I believe, flip one over, another one over. I thought they had those keywords here. I think they added that later on, where I will talk about that in other reviews. But anyways, justify, and so let the marks guide you with this. So the maximum intensity, if you look at the graph, let's go back to the graph one more time. The maximum intensity, right? Intensity goes up, goes up, goes up until this would be the maximum intensity. That's when the car literally is right in front of you. There's no distance between you and the car. So I will say this, maximum intensity found at the x-intercept, comma, since there will be no space between observer and car, i.e., lights will be the brightest. Okay, so we find it. Y2 is equal to 0. I already did. It's not a big deal. So we're going to find it, and that's 129.17, 0, because they do want the maximum intensity. So max intensity is 129.17, and just whatever units they give you. In this case, it's lumens. Something like that. Doesn't have to be exactly like it, but nonetheless. Let's keep going. Got a packed class right now. They're giving me the go ahead. Okay. Probability, shifting gears here. License plate in Ontario contain 4 uppercase letters followed by 3 digits with repetition allowed. I think that's important. Repetition is allowed. Circle the maximum possible number of license plates that begin with the letters MMB, A, MA, NI, BN, TP. So you're saying that a license plate could have M, M, B, A followed by 3 digits. So that's 10 times 10 times 10. That's what we know. That would be 1,000 plates that you could make there. Or it starts with MANI followed by 3 digits. That's 10 times 10 times 10. That's 1,000 as well. Or BNTP followed by 3 digits. That's also 1,000. So these are the options we have. We could have this many plates that we're considering, or another 1,000, or another 1,000. Okay? Think of it this way. This would technically be, you have to have a B there, so that's 1. You have to have an N there, that'd be times 1, times 1, times 1, right? Those are the 4 letters that you must have. So it's 1 times 1 times 1 times 1, and then you've got 10 options here. And because we're allowed repetition, we just keep it at 10, 10, 10. We don't go 10, 9, 8. That would be no repetition allowed. So if you add these cases up, you've got 3,000 plates that are possible. So there we go. I believe that they also, yeah, this one here, this would be no repetition allowed, 2880. So they give you some, I guess, they tried to trick you into getting a different one. Let's keep going. Never leave those blank, please, the multiple choice. A bag contains 6 white, 8 blue, 2 yellow, and 4 green marbles. What are the odds? You need to make sure you understand that odds in favor of a white marble. So we want the odds. So right away you're thinking, right, this in favor of what? A white marble. So whites will be here. And on the other side, you have all the marbles that are not white. So several ways of doing that. You just put the 6 here. Those are the white marbles. And on the other side, you'll just go 8 plus 2 plus 4. So it'll be 6 to 14. Not reduced. Sometimes they reduce it and then they just give you the reduced options here. But we can see that this is the one we're after. So that's what we go with. An alternative way to do this would be to look at how many do I have. I have 10. I have 20, right? I know that. If I add this up, there'll be 20. So you could say 6 and then 20 minus 6. That would also be 16 to 14, right? Because remember, these two always add up to your total number of marbles in this case. All right, keep going. A cookie jar contains 10 chocolate chip cookies, 12 double chocolate, 15 oatmeal. Allison says that the odds against selecting a cookie with chocolate are 15 to 37. Ryan says the odds are 15 to 22. Who is correct? So when it's something like this, just start doing some calculations here. What do we want here? The odds against a cookie with chocolate. Okay, that's what we want. So what would that look like with letters? Odds against chocolate would be chocolate here, and everything that isn't chocolate would be over here. That's when it says that word against is what you need to highlight if you're highlighting. Against the event, and the event is grabbing a chocolate, so you put it on that side. In favor would have been chocolate, not chocolate, right? Okay, so now let's put in some numbers. What do we have here? Select a cookie with chocolate. So obviously these two are chocolates. So I'm going to go 10 plus 12. Both of them contain chocolates. And 15 would go over here. That's the oatmeal, right? So that's 15 to 22. So you've actually done the calculation based on what you know. So you would have to say that Ryan is correct. Ryan is correct. And the explanation, this would count as the explanation. Okay. Maybe it just, if you want to take this further, Allison placed the total number of cookies in the odds. This is incorrect. Right? She put 37 here because I'm right. If you add everything up, if you add these two up, it is 37. So 15 to 37, that's not correct. So that's highlighting the mistake that she made. Keep going. Number 10. Describe a situation containing mutually exclusive events. Explain why events are mutually exclusive. Okay. So you could say the classic one here. Do you remember mutually exclusive? This is a visual of it. You have your universal, you have set A and set B. There's no overlap. Okay? So when you have mutually exclusive events, you can think of no overlap, or that if you wanted the number of A and B, like the elements that are in both, that would be 0. You could say that if you wanted to state A and B, we're going to talk more about this later when that unit comes, but A and B, those elements would be a null set. Okay? There'd be nothing in there. So we want events that have nothing in common. Okay? So you could say you roll a dice, you roll a die, and event A is rolling an even number, while event B is rolling an odd number. There we go. So you could even do this. This is A, this would be 1, sorry, A is even, right? So 2, 4, 6. And B would be the odds, 1, 3, 5. Universal would be 6. In this case, we wouldn't be too picky on exactly whether or not you get the diagram exactly right, as long as we see that you understand that mutually exclusive events have nothing in common. You could also say event A or set A is all students in first period class in Mr. Dirkson's grade 12 applied, and period 1 is also biology with Mr. Slavinsky. You cannot be at the same in the same class at the same time or same room at the same time. All right, next. 4 marks for this question. An organization consists of 15 women and 19 men, and you must create a 10-person committee. Is this should hopefully ring a bell. You're making committees. You're making groups, okay, of people, hands of cards, what have you, okay? So this is comms. You should be thinking combinations. We're in probability. It says how many committees can be created. How many, not the probability. It just says how many committees can be created that will include 4 women and 6 men. Show your work. You would simply say, out of the 15 women, you would choose, right, there are 15, you would choose 4, and out of the 19 men, you would choose 6. And you calculate that. That would be, do you remember how to do this? How to type in comms? 15 alpha, is it alpha zoom? No, alpha window. There it is. Combinations is your 8th option, right? So 15 choose 4 is 1365. Then we go times. I will just copy paste that and just change it to 19 and 6. That's alpha window. And then we multiply those two. You can just grab your calculator, multiply them, copy paste, right? And there it is. 37,035, 180 committees. Do not use perms here because order doesn't matter. You just want a committee. So you're not arranging. You're not arranging to take a picture. You're not making a password, anything like that. So this is combinations. So 2 marks for that. Next, if a 10-person committee is randomly selected, what is the probability that the committee will include 4 women and 6 men? We've already figured this out, right? We already know that this is question A. So when it's probability, you want favorable. I think I did NA over NU. That's what I did with you during that unit. Right, this is what you want. This is the total. NA is already given to us. I'm going to use this notation first and then just copy in the value. But this would be the number that have 4 women and 6 men, right? And what would you put down here? What's the total number of committees that are possible? How would you write that? Well, there are 15 plus 19, okay? There are 34 people. So from the 34, if you don't care whether it's women or men, if it's all combined, from the 34, you would just simply choose 10, any 10. Okay? So we want the committee of 10. Same here. Overall, this adds up to 34, sorry, and this adds up to 10, right? What you're choosing. So here you're specific, here you're just general. And make sure the bottom number is always bigger. So this one is 37 whole 35, 180 divided by, I'm just going to go ahead and copy paste. 34, choose 10, 131, 128, 140. And that's actually good enough. But if you want to turn that into a decimal, because they didn't ask state as a decimal, state as a fraction, okay, 2824, which is also 28.24%. So either one, this is good enough. That's already the answer. You're done. You've shown that you understand what needs to happen. All right, keep going. Question number 12, 5 marks. So this question will have 5 marks in total. So you always have to watch out for that. You've been asked to create a 4-character password for your computer using 26 uppercase letters, 26 lowercase, digits from 0 to 9. That's 10, by the way. Symbols. Well, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. Right? This is 10. You have 26 lowercase letters and 26 uppercase. Okay, so that we can choose from all of this. So I just want to do a count of what I have. A, how many different 4-character passwords are possible if any of the letters, digits, or symbols can be used for each character if repetition is allowed? Okay, so I don't know if you remember, but I used the fundamental counting principle for this. Okay, so we're just going to say, let's see here, 26 and 26 is 52, plus 10 is 62, plus 9, we've got 71 options. For every single one of those characters, we have 71 options. So it'll be 71 times 71 times 71 times 71. You either do that on your calculator or just know it's 71 to the power of 4. That gives us 25,411,681 passwords. Always add some kind of unit so you don't lose any. Okay, so 71 hat 4. That's what I got there. All right. You cannot use permutations here because permutations, if you go 71, pick 4, that's saying no repetition allowed. Okay, because that would be 71, 70, 69, 68. Okay. How many different 4-character passwords are possible if repetition is not allowed? Okay, so now they're placing a restriction on us. You can just choose to stick with that method. So you go 71, 70, 69, 68. Or you could go 71, pick 4. Why do I go pick? Because here order matters on your password. Right? We do care. Passwords are always order matters. You know that if you mess up on your password even by a little bit, it's going to be wrong because it's a different password. So when you do this, you get 23, 319, 240 passwords. Same here. I'm going to just show you so you remember where to find it. Alpha window is your permutation. So that's 71. Pick 4. You get the exact same answer that I have here. Okay. So you're good. So these passwords do not have any repeated characters. So if you ever made a password, there would be no repetition whatsoever. Once you've used hash mark, you cannot use it again. How many 4-character passwords begin with the letter and end with a digit if repetition is allowed? Let's see here. 1, 2, 3, 4. It says begin with a letter. That's restriction number 1. So how many letters are there? 26, Mr. Erickson, but I can do upper and lower case, right? So 52. 26 and 26. So, sorry. I usually put the number on top, sorry. Letter. So this is 52 that I have here. Times. Times, times. I will do the next one. End with a digit. This is a digit, so a number. So I have 10 there. And in between, I don't care. I can go back to what? How many do I have here? 71 and 71. Just like that. Because these ones, anything. Okay, anything can go in here. and repetition is allowed. So I don't have to worry about, hey, have I used that letter? Should this number go down? Anything like that. Do not worry about it. So we go 52 times 71 times 71 times 10. So there we have it, 2621320. So it's 2 million and something passwords. There you go. So 3 marks already done. So we have one more left on the next page, which is D. And it's 2 marks. So let the marks indicate, tell you how much work. Is it going to be straightforward, or is it going to be a little bit more than just a one step here? How many different 4-character passwords contain at least one symbol, right? That are at least one symbol are possible if repetition is allowed. Okay, so when it says at least one symbol, it means one symbol, 2 symbols, 3 symbols, and more, right? So what I'm going to do is I'm going to go total passwords minus no symbols. I'm going to go take my total. I'm going to take away the ones that contain a symbol, and then that's going to be my answer here. So let's do total. Total we already have. Okay, total is right here. If repetition is allowed, we already have that. So I'm going to write that down. 25,411,681 minus a password that doesn't have any symbols would be, let's do the math here. There are 9 symbols, correct? So you're going to go 71 options minus 9 gives you 62 options that you have if you do not want to include those 9 symbols. So you need to figure out a password that has absolutely no symbols. So that's how you would write it. So 25,411,681 minus 62 to the power of 4. That's 25,411,681 minus, that would be 14,776,336 when you do that on your calculator. And when you subtract them, this is what you get. 635,345 passwords. Okay, so these passwords have at least one symbol, but you get rid of no symbol. So now you can say, hey, these ones have 1, 2, 3, or more. Okay, so that's where the 2 marks came in. It probably gave you 1 mark for 62 to the power of 4 and another mark for you subtracting those 2. Okay, let's keep going. Finance, yay, TBM solver, all that stuff. Bridget invests $5,000 at an interest rate of 6% for 5 years. Circle the compounding period below that would maximize the rate of return for the investment. Which one do you think? Anna, which one would you say is going to give you the most money of the compounding periods? Which one? Quarterly? Okay. Well, I will take the guesswork out of it. More compounding periods per year will give highest return. And I will say that is provided that the interest rate, the amount of time and the amount of money you put in it is all the same, right? If this stays the same, this one gives you 365 a year, right? Compounded, it's calculated 365 times, 12 times, 4 times, 2 times. Okay? So it's daily is your best bet. That's going to be the most. What would be better than daily? Hourly, minutely. I don't know if there's such a thing. Secondly, anyways, The more compounding periods, the better. It's the exact opposite when you're paying off a loan, right? When you're paying off a loan, the lower compounding periods is more favorable because you pay less interest, right? Because when you're borrowing, you're paying interest, you're not earning. So, but we're talking investments here. Next, circle the asset below that is most likely to depreciate in value. Rare coin collection? Probably not. It's going to stay. Classic car? Probably going to stay. Let's continue. What else? House? Not most likely, for sure. Computer? Yes, that's most likely to depreciate over time. So, computer, cell phones, just a regular car, right? They said classic cars, so classic cars are like collectibles, so they usually stay higher. Let's keep going. 3 marks for this question. Mr. Chang is 64. That's near retirement. Near retirement. That's very important to note. At 64. Plans to retire next year. They're confirming that. His portfolio includes the following investments. So he's got 50 grand in mutual funds, 100,000 in stocks, 20,000 in guaranteed investment certificates, which we call GICs. You would have to say that this is higher risk. Mutual funds and stocks, they're considered higher risk, stocks being the most risky there. And GICs are low risk. Okay, that's just to review that concept. Does this portfolio is just a bunch of investments, right? You're diversifying. Include an appropriate level of risk for Mr. Chang at this stage in his life. Explain your answer. And I would say it does not. Given that he is near retirement, he should have the majority of his money invested in lower risk funds or something like that. He has, right? He has 150,000. He has most of his money in high risk investments. He could lose it. He could lose a lot and not have enough time to gain it back. And the way you could answer this varies greatly, right? To be honest, even if you said yes, you would probably say, well, you make more money, you have a greater return here. If you justified it properly, you would have been okay. But here it is. Explain is what they were looking for, not just it is not. That would not have been good enough. Okay. 1 mark. Next page. Mr. Chang. Mr. Chang's investments had the following returns last year. Mutual funds increased by 12%. Stocks decreased by 4%. And GICs had an annual interest rate of 3%. Calculate the rate of return for the year for this portfolio. Show your work. So it says mutual funds increased by 12%. So we're going to figure out, we're going to go times 0.12. So we're going to figure out 50,000. We're going to find out what 12% is, and that's 6,000. So the return for the mutual funds is 6,000. End of the year, what you have would be 56,000 here. Boom. Stocks went down by 4,000, but I'm going to go times 0.04. Oops. So we're going to go minus 4,000. So you end up with 96,000 at the end of the year. GICs, 3%. So you go 20,000 times 0.06. So that's 1,200 bucks that has been earned. So at the end of the year, you add that to your initial amount. And there you have it, 21,200. Now they want the total. Okay, so you add this up, that's 170,000. You add this up, you got to be careful. 6,000 minus 4, that's 2,000, plus 1,200, that's 3,200. So at the end of the year, you will have, wait, did I get this right? Oh, I went 10 point, sorry. I noticed that I went times point, because 3 times 2 is 6, right? So I made that mistake there, sorry. Let's change that to 600, which means this is 20,600, which will change this significantly. So 6 minus 4, that's 2,000, plus 600, that's 2,600. Please fix that. There we go. So at the end, you invested 170 that year. Overall, you gained this much. So you add these up again to get 172,600. Various ways. You could have added these up. You just added these up. No matter what, you get 172,600 there for the 2 marks. However, I find that this question isn't very clear. It's like fill in the chart, or it actually says, if you read carefully, calculate the average rate of return for the year. That's what, so this is supposed to help you. You remember what the rate of return is? It's earnings, could be interest, whatever, divided by what you invested times 100. That's really at the end of the day. So the earnings could be in the stock market where it's just a fixed dollar amount. It could be interest earned, you name it. So rate of return, we would say this. How much did you earn in total at the end? You earned 2,600. Okay, so this number goes there. How much did you put in out of your own money? That's the 170,000. Just multiply that by 100. And I'm just going to give you the answer. That's 1.53% overall. Even though every single investment could have their own rate of return calculated, we did the overall. So there we go. 2 marks for that. Let's keep going. 5 marks. TBM solver probably. Amar dreams of retiring at the age of 55. He had planned on starting to save for his retirement at the age of 50, but his financial advisor does not agree. He recommends that Amar start to save sooner. If Amar invests $1,000 on his 25th birthday and contributes $200 every month on an account that earns 8% compounded monthly, what will be the value of the investment on his 55th birthday? Show your work. If it's compounded, folks, you can always use your TBM solver. If it's simple interest, please do not do that. And I would strongly recommend you have a legend on your study sheet telling you what these entries mean, okay? So you got to press apps, right? You go apps and then finance, and then you go TVM. That's just a reminder. It's been a while. All right, let's fill this in. I usually start at the bottom when I do it with pencil. Compounding periods per year. If it's compounded monthly, I have 12. Payments per year. Are there payments? Yes, there are contributions, right? Like you're paying into. So it's every month. So it happens to be the same. Okay. Can I just say this? If there are no contributions, do you remember what happens to these two? If there are no contributions, if payment is 0, then by default, this is going to be the same as that anyways. Okay. In this case, there are payments and they are monthly as well. Future value, we want to know what that is. Payment, 200. But it's important that you know that it's 200 negative because it's leaving you. It's going to the bank. Present value is any big amount that has been submitted at the very beginning, which is $1,000. I'm going to go minus 1,000. Interest rate is 8. And N is the years times PY. Okay, it's always based on what's in here. This is months, right? Monthly payment. So this would be the number of months when you're done, when you calculate that. So how many years are we talking about? 25th to the 55th birthday. I'm actually going to show that work here. Times 12. That is 30. Make sure you use your calculator the day of, okay? Don't risk it. That would be 360. So N is going to have the entry of 360. Now we're ready to solve. So 360, 8, negative 1,000, negative 200. I'm going to put a 0 there, 12, 12, and make sure you have it set to end. Future value, alpha, solve, right? Alpha, enter. To do that, 309, 309, 007.62. That is your future value. That's what you're expecting to have back then. And it makes sense that it's positive because then it will be coming to you technically. Okay? You're able to take that out and have that as an investment. B, if Amar invests $1,000 on his 50th birthday, how much will he have to contribute every month to match the final value of the investment in A? Assume that the interest rate and the compounding period stay the same. I will do this again. There we go. So basically what I'm saying is I want the 309.00762. Right? I want that in the future. Everything stays the same, compounding, and you're making monthly payments. They want to know what the contributions will have to be. What are my payments going to be if I put in $1,000 still, just like before? Interest rate is the same. But here it's different. N is going to be different because you're starting on your 50th birthday and you want to end on the 55th. So this is basically 55 minus 5, sorry, minus 50 times PY. So that ends up being 5 times 12, which is 60. So in 60 months, you want to still come up with the same amount. That's kind of ridiculous. And I'm just going to go ahead and go 309.007.62. I'm going to type it in just to 2 decimals. I will find my payment. Everything else, just make sure you change that. So I change that to 60. I keep everything else the same. So I'm going to figure out my payment. Alpha, enter. Here it is. It's negative 4185.23. So he has to make monthly deposits of 4,085, 4185.23. So that's how much more he has to put in, or not how much more, but what the payment has to be to meet that same end goal. C, calculate the difference between Ammar's total contributions in A and in B. Show your work. Okay, the difference is you have to subtract between total contributions in A and in B. Total in A, and part A would be what? I made, you go back, you made 360 payments of 200 bucks, right? These are all your payments, plus the $1,000 you put in. That's what it's asking for there. So 360 times 200 is 72,000 plus the 1,000. We're talking that you put in 73,000 in A. Total in B, you made, if you go back to N, you made 60 payments of 4185.23, okay? Plus, you still put in $1,000 from your at the very beginning. So let's calculate that. So that part is 251,138 plus 1,000. So that would be 252,113.80. Make sure you have that. So now we have how much was put in from your own money in both scenarios, but we want the difference yet. Look at how much more you had to pay in the second scenario because he started so much later. That's why it's important to start soon. Difference, 252,113.80. Always read, did I answer the question? And you get 179,113.80 is the difference. This is your final answer. So again, 3 marks at the beginning. Should have been straightforward. Here you would have probably received 1 mark if you figured out the total amount you put in in each scenario, and then 1 mark for the difference. Okay, let's keep going. Don't have much left. Okay. Try to make this work here. The Reimers have purchased a house valued at $250,000 and have made a down payment of $25,000. Calculate their monthly mortgage payment if they obtain the mortgage, amortized over 15 years at an interest rate of 5.5, compounded semi-annually. Show your work. And this is what they mean by showing your work. And having the entries here. Try to think really hard, like what goes where, okay? Compounded periods, semi-annually, what does that means? Twice a year. PY, they're saying calculate their monthly payment, so this has to be 12. Future value, if it's a loan, you want it to be 0. My payment is what they're asking me for. Present value, it's 250,000 minus 25,000. I show that right here because that's what you're gonna have to borrow, what's left, which is the $225,000. Positive or negative? It's positive because, right, the bank is giving you the money to purchase this. Okay. Interest is 5.5, and remember it's number of years times whatever is in PY, which is 12. And that's 180. Let's go ahead and figure that out. what? This is 180, 5.5, 225. Payment, I'll figure it out. Future 12 and 2. So you go to your payment, alpha enter. That is negative, but we don't worry about that. When we have our answer, this is the monthly payment that will have to take place. If you did put a negative in here, negative 225, and then figure out your payment, I guess it would have been positive. In this case, it wouldn't have affected too much, but if you have an initial investment and a payment, then it gets tricky. But just stick with the way I taught it and you'll be fine. Next, how much equity? That should ring a bell. The bell's about to go, by the way. Equity will the Rammers have in their house after 5 years? After 5 years, if the house appreciates at 2% per year. Equity, if you remember, is the value of the home, right? Current value minus balance at that time. So the value in 5 years minus the balance owing. So we can do it in various ways, but current value, you would be putting this down 250,000 times 1 plus the rate of increase is 2% to the power of 5 years minus, we'll actually use this function, balance owing, right? And then you go 5 years times whatever PY is, which is 12. So we clean that up a bit, 250,000 times 1.02 to the power of 5. Don't double, divide by 100. Minus, I'm going to do the balance already. We do this. You got to quit this. Remember, it's always based on what's on your TVM. Okay, so call the balance. It's balance of 60. And so you owe 169,197.53 at that point. I'll figure out what this is. Some of you like to do the 1.02 to the power of 5 first. Nothing wrong with that. Then you multiply it by 250,000. You take the value of the home, not the 225 that you borrowed, okay? So that's 276,020.20 minus 169,197.53. When you subtract that, you get 106,822.67. This is a very loaded question. You get 1 mark for figuring out this, 1 mark for figuring out the value of the home in 5 years, and then 1 mark for actually subtracting. That's why this one is worth 3 marks. So lots at stake here. Make sure you don't leave that blank. Design and measurement. I think I will have to make a third part for this one. So we'll just stop here for now. Thank you.